Okay, so we are going ahead and getting started on our next one. And so what we're going to talk about on this one is our degree 3, which is our cubic. Okay, and if you'll remember, our basic form from earlier was ax cubed, because it's our highest degree, bx squared plus cx plus d. Now remember, you don't have to have, the only one of those you have to have is the x cubed. Okay, so an example, you could have 2x cubed and that would be enough. If you don't have the cube, then it's a square. So you have to have the cube. You could be missing, though, any of those terms that you wanted. I could have 3x squared plus 2x, and that'd be enough. Okay? I could have 9x cubed minus 1. Any of those would work. But again, the key is, in order for it to be a cubic, you have to have a third power. Whoops, that one is bad because I just, thank you for noting that. There you go, 3. Okay, so it has to have a third power. Okay, let's talk about what the graph looks like. Now, this is the one that I usually call the disco. That is not a mathematical description, but it is what I use because typically most people know what I'm talking about. We're probably getting to generations where they don't know what the disco is. But anyway, it looks kind of like that. And so all of the graphs will be of that form. And again, the question is always what's going to happen on the x-intercepts on that. So we're going to start off with what we're going to call one real solution. Okay? So one real solution. Okay, and that graph, what it's going to look like is I'm going to have it only cross at one spot on my x-axis. Now, who knows what it does on the other part of it, just that it never comes back down and crosses. So it's going to have one real solution, guys, but what this will also have is 2 imaginary solutions. Okay, 2 imaginary. Then the next one that we have is going to be when we have, let's see, what I want to do. We're going to have 3 real solutions. Now, this one actually has 2 ways it could look. So I'm going to show you the easiest. 1, 2, 3. There he goes. 1, 2, 3. There's 3 real solutions. Very easy to find how they do. Okay, so that one's pretty easy. Let me show you the next one. So this one also has 3 real solutions. Okay, but it's going to look like this. Okay, and so hopefully you understand that even though I've got this one is your multiple root. Okay, multiple root. So I have 3 real solutions, okay, but only 2 different solutions, okay, because one is a multiple root. Okay, so the way I would write this out, guys, let's say I'm going to call this the number -4, and we'll call this 2. So the way I would write this answer, I would say x equals a -4 and 2, and then I would put multiplicity, multiple 2. That's what we do that. We say that one occurred twice, but we still have 3 answers. Okay, that's a key. Let's see, what else do I want to do? I have another graph here. What do I want to show you? Oh, I know what I was going to show you. Let's see. It could just be something, again, it doesn't have to, oops, let me get that way. Here, that's what I was going to do. There we go. So it could be that it hits over here, that hump that I showed you up here on this one is kind of over there. So again, this one would still have, on there, it would still have 3 roots, okay? Whoops, let me call that 1 real root, again, 2 imaginary. Okay, so there's my 1 real. These in here somewhere would be the imaginaries. Okay, on these with the 2 imaginary solutions, you would have to run the quadratic. Okay, possibly on that. not necessarily would you have to, but that's also always a possibility. Okay, let's look at if we flip it upside down. Okay, so I'm going to take these same graphs and we're basically just going to flip them upside down. So now when I look at it, if A is less than 0, what's going to happen is it is going to start up here and go down the other direction. Okay, so again, this one would have 1 real. Okay, right there. And it would have 2 imaginary. Okay, let me give you another one. And so this one, well, it could still come from here and be this. So that would be our 3 reals. Okay, you just go in the other direction. We could have, let's see what I did, multiplicity on there. So this would be, again, when I look at it, again, I still have 3 real solutions, but 2 distinct solutions, okay, because one is a multiplicity. Okay, so again, you would just need to state that. And then the last one, what do we have that do? Let's see. Let me think what I'm trying to do here. I need to make, what's going to make it look like going through, oh, here, be this way. There we go. Okay, so there would be, again, 1 real solution. Okay, and 2 imaginary. Okay, so what I want you to see on here is, if you'll look, they all add up to 3. 1 and 2, 3, again, 1 and 2, 1 and 2, 3 on there. But when you're looking at cubics, guys, you only have the possibility of 1 real or 3 reals. And the reason, again, goes back to our imaginary numbers. Remember, they come in pairs. So anytime I have an imaginary number, I will have 2 of them, 4 of them, 6 of them, so forth. So that is our cubics. We'll stop here and then we'll go to 4s.